Asphalt roads seem like simple black ribbons laid across the landscape, but behind every mile lies an enormous industrial system of quarries, crushers, dryers, mixers, chemical additives, dump trucks, pavers, rollers, and quality control labs that together build the backbone of modern transportation. Highways depend on asphalt strong enough to survive decades of heavy truck traffic, scorching summers, freezing winters, rain, oil drips, and constant vibration. And today on The How Factory, we're going deep inside that system to reveal how asphalt is crushed, heated, mixed, transported, paved, and compacted with engineering precision. What looks like ordinary pavement is actually the end result of thermal chemistry, massive machinery, and construction choreography, executed on a scale most people never see. The process begins with aggregates, crushed stone, gravel, and sand, which form roughly 90 to 95% of asphalt by weight. These aggregates are mined from quarries using blasting charges that break solid rock into manageable chunks. Excavators load the rock into haul trucks, which deliver it to primary crushers. Jaw crushers and cone crushers reduce the rock to specific sizes, while vibrating screens sort the pieces into precise gradations. Highway asphalt requires a carefully engineered blend of coarse stone for strength, intermediate stone for stability, and fine material for smoothness. Quarry operators adjust crusher settings and screening parameters constantly to maintain the right distribution. The final blend travels by conveyor to stockpiles that feed the asphalt plant, an industrial facility that functions like a giant oven and mixer combined. At the asphalt plant, aggregates first enter the drying drum, a massive rotating cylinder heated by powerful burners. These burners, fueled by natural gas or oil, blast temperatures exceeding 300 degrees Celsius into the drum as it turns. Inside, drying flights lift and tumble the stone, exposing it to hot air and evaporating all moisture. This step is critical because any trapped water would instantly vaporize when mixed with hot asphalt binder, causing steam explosions and improper coating. Sensors monitor moisture content continuously, saving fuel by adjusting burner output. From the dryer, the hot aggregates travel via conveyor to vibrating screens atop the mixing tower. These screens separate aggregates into compartments by size, ensuring the plant can create precise recipes for different road layers: base course, binder course, or surface course. Meanwhile, asphalt binder, the black, sticky petroleum material that glues everything together, is stored in insulated tanks and heated to around 150 to 180 degrees Celsius. Binder is delivered to plants by tanker trucks and pumped into storage tanks equipped with heaters, mixers, and level sensors. Modifiers may be added depending on the highway's climate or traffic conditions. Polymers enhance elasticity for hot climates. Rubber from recycled tires improves durability, and anti-stripping agents help binder cling to stone even in wet environments. Each additive must be metered and blended with exactness because small changes can heavily affect road performance. With hot aggregates in the tower and hot binder ready below, mixing can begin. In a batch plant, aggregate proportions drop from their bins into a weigh hopper, ensuring precise measurements every cycle. The hopper then releases them into a twin-shaft pug mill mixer, where binder is sprayed onto the hot stone. Massive paddles churn the mixture, coating every particle evenly. In just 30 to 45 seconds, a complete batch of asphalt, usually a few tons, is ready. In a drum mix plant, the process is continuous. Aggregates flow through one end of the drum while binder is injected midstream, coating the stone as the drum rotates. Either way, the result is a hot, black mixture at roughly 150 degrees Celsius, ready to leave the plant quickly before it cools. From here, insulated dump trucks line up beneath loading silos. Gates open and tons of asphalt pour into truck beds, steaming and glistening. Trucks tarp their loads immediately to retain heat. Asphalt must remain hot to spread properly. Dispatchers coordinate dozens of trucks to ensure a continuous flow of material to the paving site. Interruptions can lead to cold seams, rough patches, or inconsistent compaction. Timing is everything. Asphalt mixing, trucking, paving, and compacting all must synchronize perfectly. At the construction site, graders and dozers have already shaped the roadbed, building proper elevation, slope, and drainage. Beneath the asphalt lies compacted gravel or stabilized subbase, the structural foundation that prevents sinking and cracking. When the hot mix arrives, it is delivered to the asphalt paver, a machine that works like a conveyor-driven ironing press for roads. The truck backs up to the paver and releases asphalt into the hopper. Augers inside the paver push the material outward, distributing it across the width of the screed. The screed, a long, heated metal plate, floats on the asphalt, leveling and shaping it into the correct thickness and smoothness. Automatic grade and slope sensors use lasers, string lines, or GPS to maintain perfect height and cross slope, ensuring water drains off the road instead of pooling. The paver lays the asphalt continuously, forming a fresh mat behind it. This mat begins cooling immediately, so rollers must follow close behind. Compaction is where asphalt gains its strength. Steel drum rollers and pneumatic tire rollers make multiple passes to squeeze air voids from the material and lock aggregates tightly together. The exact number of passes depends on temperature, roller weight, mix design, and mat thickness. Rolling patterns are calculated precisely. Too little compaction leaves voids that allow moisture infiltration and oxidation, leading to early cracking. Too much compaction can crush aggregates or expel binder, weakening the road. Infrared sensors monitor mat temperature to guide roller operators on where and when to compact. Compaction must be completed before the mix cools below a critical temperature, typically within 10 to 20 minutes. Highways often consist of multiple layers. The base course, thick and strong, provides structural support. The binder course sits above it, adding durability. The surface course, the top layer, uses smaller aggregates for a smooth, quiet ride and excellent skid resistance. Each layer is paved and compacted separately with tack coat, a thin layer of sprayed asphalt emulsion, applied between layers to ensure bonding. Without proper bonding, layers can slide or delaminate under traffic, causing potholes or rutting. Throughout paving, quality control teams take core samples and run density tests using nuclear gauges or intelligent compaction systems. These systems use accelerometers and GPS sensors built into rollers to map compaction quality across the entire road. Lab technicians examine binder content, aggregate gradation, air void levels, and asphalt temperature. Any deviation triggers adjustments on the fly, ensuring every stretch of highway meets exact engineering standards. Edge work and joints require special attention. Longitudinal joints, where one lane meets another, are compacted using specialized rolling sequences to ensure a tight, durable seam. Project crews heat the joint area to create seamless bonding between passes. At intersections or ramps, smaller pavers and hand crews shape transitions. Once cooled, the asphalt mat hardens into a flexible pavement, designed to withstand millions of load cycles. After the asphalt cools completely, the road enters finishing stages. Line striping crews arrive with paint trucks equipped with lasers and bead dispensers. Thermoplastic striping, reflective glass beads, and rumble strips are added depending on the project. Guardrails, signage, and barriers are installed. Shoulders are graded and compacted. Drainage ditches are shaped to channel water away from the road. Within hours or days, depending on specifications when used, the new pavement can support traffic. Behind the scenes, modern asphalt production incorporates sustainability initiatives. Reclaimed asphalt pavement, RAP, from old roads is milled off, crushed, screened, and fed back into new asphalt mixes. Recycling percentages can reach 20 to 50% or more depending on mix design. Warm mix asphalt technologies lower mixing and compaction temperatures by adding foaming agents or chemical additives, reducing fuel consumption and greenhouse gas emissions. Plants capture dust from drying drums and re-inject it into mixes as mineral filler. Noise-reducing surface mixes help urban neighborhoods by dampening tire noise. Porous asphalt allows water to drain through the pavement, reducing runoff and improving safety during storms. What makes asphalt road construction remarkable is the coordination of massive moving parts.